In problem 4, chapter 5, section 3, we are given a velocity function, and here's where our velocity is going to be a function of time, and we're actually taking into account air resistance, because we can see that our velocity function is eventually going to max out at some value. We're going to have some kind of terminal velocity. All right, so let us look at what the question is. Choose the correct expression for the distance you fall in t seconds, capital T seconds. So this velocity is the rate of change of our distance. So we want to integrate. So if we want to know the distance we fall in capital T seconds, we're going to want to integrate our velocity function with respect to t. And we start falling at 0 seconds, and this is how far we've fallen after t seconds. The units here will work out because v of t is measured in meters per second, and dt, which is just a little section of time, is measured in seconds. And so the seconds cancel. This will be our distance in meters that we've fallen after capital T seconds. If we jump from 6,000 meters above the ground, we want to find, the next question says, if we jump from 6,000 meters above the ground, we want to find an equation whose solution is the number of seconds you fall before hitting the ground. Why this problem got to be so scary? Oh well. What we want to find out is we hit the ground after a certain amount of time, and we have fallen 6,000 meters. So if we solve the integral from 0 to t of v of t dt, we want to find out when the distance we've fallen is equal to 6,000 meters. So the solution to this equation will tell us how long we've been falling when we hit the ground. So at t equals 0, we're starting off at 6,000 meters. So we want to find out how long it takes us to cover 6,000 meters if this function is our distance that we've fallen. Any questions? So the third part is to actually attempt to solve the equation, to solve this equation. So we want to know the integral. We want to solve the integral from 0 to t of 49 times 1 minus e to the negative 0.2 little t dt equals 6,000. So we could find the antiderivative of this function and then solve the resulting equation. But we do have technology on our side here. So let's take a look at our calculating machine. Let's see what this function looks like. And then we'll just integrate it until we get an area of 6,000. So we have 49. Let's actually integrate this function. Actually, I don't want to do it from a graph. Sorry, I just completely changed my plan right in the middle of everything. Let's put this function in. 49 times 1 minus e to the negative 0.2 t. Let's see, that closes the exponents. That closes the times 49. With respect to x, from 0 to, and then the next number that I'm going to put in is how long I think it's going to take us to fall. So I just need to pick something. How long, what happens after 60 seconds? So here's what we're going to do. This is the best what we're going to do is we're going to put this into our calculator and keep plugging in t's until we get 6,000. Mainly we're doing this because we haven't done a lot of work in finding antiderivatives. So we don't want to risk messing up finding the antiderivative. We've got a friggin' machine that's going to help us. And it says round your answer to the nearest integer. So let's use a machine to accomplish this problem. So let's put this into the definite integral. And change the value of t. Keep changing the capital T until we get 6,000. So that's going to be our strategy. We're just going to brute force this. We're going to do the main thing that we do in every new math problem. We guess. So how long will we fall in 1 minute? 2,695 meters. So I'm just going to keep track. So different values of t, and then our distance. At 60 seconds, we've fallen 2,695 meters. So what if we do 2 minutes, 120 seconds? So I'm just going to do the same integral, but change the 60 to a 120. 5635. So I picked 2 minutes because 2,600, I need to go twice as far. So what if I just have twice as much time? But now I'm not going to go that far again. I'm not going to go all the way out to 3 minutes because it looks like we're pretty close. So what about 130? So try 130. 6125. So now I know I'm between 120 and 130. That's not as close as I want to be. I want the answer to be close to the nearest integer. I want to be to the nearest integer. So I'm going to see what's in between 120 and 130. So I'm just going to pick these two. And that's going to tell me to do 125 seconds. 25. 125 is 5880. So now I know I'm between 125 and 130. And I'm just going to, there's only a few choices here. So if I keep counting up, if I go up to 128, I'm at 6,027. That's overshot again, and then 127. I was at 5978. So now we just look at the 128 and 127. This is where we want to round to. So which one of these is closest? And it looks like this one's 27 off of the 6,000. The 78 is 22. So it looks like 127. So 127 is closest. I like how the tolerance is still plus or minus 2%. So round to the nearest integer, plus or minus 2%. What is 127 times 1.02? So we could answer up to 129.5, which is, and then let's see. And 124.46. So, but 127 is the closest one. We don't need, we can actually, anyway, that's beside the point. So at this point, once we set up the integral that we want, we can just guess and check, which is our favorite math trick. 128 was too high, 128 was too low. So it's between 127 and 128. 27 is closest at 22 units away from 6,000, and 128 gave us 27 units away from the 6,000. So 127 is closest. We stopped here because we were only asked to round our answer to the nearest integer. If we were asked to round to the nearest tenth, then we would just keep going. It's 127 point something, so let's start in the middle. That's really close, but it's above. So if I look at the lower one, so it looks like to the nearest tenth, I would go with 127.5 because that's 2.5 off. Oh wait, nope. I would go with 127.4 because that's 2.4 off. If I wanted to go further, if it said round to the nearest hundredth, then we would just keep going. Between 40 and 50 is 45. 45 is really close, so what if I went with 44? So now we're 5 hundredths off at 45, and we're 44 hundredths off at 44. So I would go with 0.45. Any questions? The other reason I like doing the calculator part is that if we found the antiderivative, we would probably be resorting to a calculator to solve the equation. So why not we back one step up and use the calculator as soon as the calculator becomes available to us? Any questions? Don't use a calculator on the last step. Use the calculator as soon as it becomes available. All right, let's pause the video here and talk about another problem.